before anything exciting happens. All right, folks, here we go. The plan for today, we got some notes on 3 minor items, which might have become 4 items. I think they are. I can't remember. Then we're going to talk about sorting. So if for some reason you're not in the room when I cover that, you definitely want to watch this video that I'm recording right now. And then we're going to do a Google form practice. And then we have a practice REPL. And then we're going to use the word group class that we wrote last time, although I'm giving you my version of it, to write silly sentences. If you were in my regular programming class, you remember this assignment where you end up with sentences that say things like, Mr. Hayes runs pathetically.
Oh, I remember that.
Yeah, so we're doing that. Yeah. I thought you might. And then finally, I'm asking you to do 9 through 18 on the AP Classroom. That's by Wednesday before class starts. You know, today, great if you had time, but don't stress about it, but get it done before our next class. All right, 3 minor items, which might be 4. Listen, in looking over the MCQ progress check for Unit 7, I found 3 quirks that I hadn't already mentioned to you, so I'm doing that now. Linear search, sometimes they call it a sequential search. That's the same thing. So I think it might have been in the 9 problems you did Wednesday. I don't know. So don't stress. If it says sequential search, that's a linear search. It's in order, a sequence, you know. Second, check this out. When you create an array list, it's possible to put the object type, to not put the object type on the right side. They let you do that. And that was in one of the problems. I talked about it with a lot of you on Wednesday. I'm sorry about that. Listen, if you do this in REPL, it says main.java uses unchecked or unsafe operations. So what I'm telling you is it lets you run it. It's not appropriate. And I want you always to put the object type on both sides of the equation, like it shows at the very bottom. Always say, if you're doing an array list of strings, say array list string. So if you don't put it on on my test, I'm going to take a point off because I want you to have good behavior, not what is generally barely allowed with a warning. Yes. It was the one where I think it was 1 and 3 were the answers. Yeah. And if you got it wrong, I'm not taking any points off. I'm now explaining why. And by the way, I updated my slide deck from that day to explain the very first day on array list to say, hey, by the way, you can avoid putting it here, but please don't. Okay. Number 3, I also forgot to tell you that the remove method returns the thing you removed. Like it hands it to you. Like, okay, I'll take it out of the list, and here it is. So in this example, I made a array called names, array list called names. I added Gilly, my dog, Elvis, my now deceased rooster, and then I removed Elvis, I guess because he died. This code prints Elvis. So when you say names.remove, it gets something out of the array, removes it, and then it prints it. So here's another example. And I do say you don't have to do anything with the thing that got removed. So here's, I put Gilly, Elvis, and Gandalf on here, and then I removed all of them. But check this out. I removed it in 3 different ways. In one way, I made a new variable called old name, and I removed one and threw it into the old name. Right? So you can do that. This line, I just removed something and didn't store it anywhere, didn't print it, didn't do anything. That's fine too. And then finally, I removed the last one, and then that one I did print. So those are all legit ways to remove stuff. You can save it somewhere, you can just remove and not save it, and you can print it. Any questions? Oh, sweet. There were just 3 things. Well, 10:28. I don't know what to expect. I mean, what do you want? Do you want me to start? Do you want to just do what you're going to do right now? Oh, look at him. Here he goes. Tackle him. Get him. We got security for you. Yeah, I got my earpiece. Yeah, I've got a runner. I've got a runner from the Maker Lab.
Take him down. Right on the roof.
And him. Um, if my guitar was hanging right here where it used to hang, I would pull it out and play a little song for you. Well, when COVID hit, they gave us an instruction to just almost 2 years ago to come into our classroom area and take down everything from the shelves and the walls and just so I took down my guitar hanger piece and the guitar and I put it in. Here's the kicker. I don't know where I put the hanger. I know where the guitar is, and yeah, that the guitar was a $200 mistake. I mean, not mistake, a purchase. But the hook was like a $10 or $15 thing, and I can't find it. And yep, I could 3D print a hook. The 3D printers, the plastic of those are not strong enough to hold my guitar. I could laser cut the wood to make a hook, but that would. Oh, yeah, I mean, it'd be an interesting problem. But there's a box. I still have like 2 boxes in my attic office that contain stuff of mine, and it might be there. Folks, it's 10:30. I don't know. I had a feeling something might be happening at this point. So I turn around, cover my eyes, and then take care, everybody. Yeah. Bye. You know what's hilarious? I forgot to take roll before they left, but Trey wasn't here, right? Trey didn't just walk out. All right, everybody. What's fun is all that was recorded, so let's say hi to Tosh. Everyone say hi, Tosh. Hi, Tosh. Hey, Tosh. Oh man. Let's do this now. Now that awkward moment is over, folks. Today we're talking about sorting. And in AP Computer Science A, the class you're in, there are 3 algorithms. So I shouldn't have used the word methods. 3 algorithms for sorting that you need to be familiar with. You're not going to be asked to code these on the test or by me. Mostly, I might ask you to code one of them, but you have to be able to recognize them and know what they mean. So here we go. We're going to talk about 2 sorting algorithms: the insertion sort and the selection sort. First, the third one we're going to do another day, another unit. We're just doing these 2. Yeah, I forget what the third one's called. We do it in unit 10 at the end of the year. Okay, insertion sort. Check this out. So you got a list, whether it's an array or an array list. You got a list of items. You start at the second item in the list, and then you go backwards and see if that second item in the list should be first. All right. If it is, you put it there and move the other one up. You like insert the one you're looking at. Then you go to the third item in the list, and you go all the way back to the beginning. Should this go anywhere earlier? Yes or no, yes or no. And if not, you leave it there. Then you go to the fourth item. So basically, anytime So at some point you're all the way at the very end, and you see, hey, should this go anywhere earlier? And if you find a spot where it should go, you put it there and you bump all the other ones up. Uh, so what will this look like here? Well, you might be given actual code. I know for a fact on the AP Classroom, the multiple choice question problems, you're going to be shown like, okay, given this insertion sort, what is the value of whatever after 5 passes or something like that. So we're gonna look at this. So let's say we were going to sort this data using the insertion sort. And this is a classic question you might get on the AP test. What would this array list look like after 3 passes? So here's what we're starting with. 5, 2, 6, 1. It's not sorted, right? I'm imagining sorting from lowest to highest. So after one, the first pass, you would look at this 2. Remember I said start at the second element and see if it should go somewhere earlier. So yeah, the 2 is smaller than 5, right? So the next row, after 1 pass, the 2 got moved first, the 5 got bumped over. Make sense? Now, the next pass, we're looking at the 6. Here we go to the third item. And the algorithm would check, should this go anywhere to the left? Nope. So after pass 2, nothing changed, but it still counts as a pass. And now we're looking at the 1, and yeah, the 1 obviously should go on the far left. So basically it takes the 1, it puts it here, bumping everything over. So after 3 passes, the 1 gets moved over. So if I said, what does this look like after 3 passes? In this case, it happens to be fully sorted. Do you want to go through that again? All right, here is an algorithm that does this. And it's kind of nuts. So you can see why I'm not making you code it. But I said, let's walk through this. I do a trace, and it's kind of nasty. I don't mean in a, just gnarly would be a better word. Here's what's up, 10, 8, 3, 4. So at the very start, 10, 8, 3, 4. When it gets to line 10, it's at this point, it's bumped the 10 over because it knows the 8's going to go right here. This code does this thing where it bumps everything over as it goes. It's not quite exactly the way I described it. It doesn't go all the way to the, and I'm going to put it here. Now I'm going to move everything. It just moves things as it sees that it would need to. Anyway, so the first thing is looking at the 8, and it's like, all right, boom. I put the 8 there. It moved the 10 over, and then put the 8 there. Now, we're at line 10. The 3 definitely has to get moved over, right? So it moved the 10 over, then it moved the 8 over, and then it put the 3 here. And then finally, the 4 has got to move over. So it moves the 10 there, it moves the 8 there, it moves the 4 there, and then it puts the 4 right where it's supposed to go. So anyway, you're going to be asked to look at code like this and go, okay, it'll say things like, what's the value of, how many times does line 10 execute, and then you'll be like, oh boy, I got to trace this. And, that's where you want to get a piece of paper out and do it carefully. Listen, this sort method is relatively easy to code. I mean, it literally was those 10 lines of code or 12 lines of code. That's not too hard. And it's quick for small data sets. It gets very inefficient for large data sets. Imagine, so you got 1,000 things. Boom, it does it in a second. But if you had 1 million, think about it. It's on the 900,000th element. The code has to look at 900,000 elements before it knows if it's in the right spot. And then it's 900,001, and it's got to look at all those elements beforehand. And when there's 1 million, it's going to look at 1 million things before it says, yeah, that millionth one is in the right place. You can see that's not very efficient. Anyway, I just want you to know that. It's relatively easy to code, quick for small data sets, but inefficient for large data sets. Next sort method. I don't know why I like this one better. It's called the selection sort. Uh, start at the first element and then go through the entire list, the array or array list, and find the smallest item in the whole list. Just find the smallest item in the whole list. Put that in the first spot. Trade places with the one that was in the first spot. So you're in the first spot. Maybe if the first spot was the smallest, then you wouldn't move it. But if let's say the first spot isn't the smallest, you go find the smallest thing in the whole list. Awesome. All right. Now trade place. Then you go to the second spot and you find the smallest item in the whole rest of the list. Put that in the second spot. Trade places. You just keep doing that, and pretty soon, it works itself out. So let's look at this. One of my favorite starting points is Jenny. Who can I turn to? 8675309. So on this one, we're at the 8, and we're going to look through the whole list and find the smallest number, and we're going to trade places with that and the 8. So the next one, after one pass, we found the 0, and we swapped the 0 and the 8. And you might say, well, that's not very efficient. We know, well, 8, yeah, no, it's pretty good. The 8's in the right place, but that was just luck. Next pass, we're looking at spot number 2 or index 1, but the second spot, we're going to go find the smallest number. I think that'll be the 3. We're going to swap the 3 and the 6. Now I know as a human, you might say, well, I could see that the 6 shouldn't go there. But remember, this is a computer, and it can't just look at all of them and go, oh, I can move this here and move that there. Like you have to have an algorithm. I mean, you could code your own. We could code the Bolt algorithm for sorting that could be different. But this one just looks at the first element, finds the smallest thing in the whole list, swaps places. Looks at the second element, finds the smallest element, swaps places, and so on. Let's look at the next one. We're looking at this spot here. What's the smallest number to the right? The 5. So it's going to trade the 7 and the 5. Bless you. And then it's looking at the 4th spot, and it's going to find the smallest element from there to the end, which is the 6. And now you'd say, all right, well, we're done, right? What's classic is the algorithm has to keep going. It doesn't know we're done. I mean, you could say, well, we could add code that would check if it's done, but think about how inefficient that would be. Do you run it after every time you swap here, and then you're like, oh, I'm going to check everything. Like, oh, no, we're not done. Oh, no. Like that. You might as well just finish it. So I said the code would do a few more passes, like 3 more, but nothing would change. So a classic AP test problem would be, what's the contents of this array after 5 passes of the selection sort? And the reason I think they call it selection is you've selected this one thing, and then you're like, fine, should I be swapping this with something? You just trade places. I don't know why they call it that. The next slide shows the selection sort implementation. This one's easier to read, actually, than the other one. We got a for loop. We're going through all the elements in the array, except for the last one. We don't have to check the last one because you can't. If you've been swapping them all along, then the last one's in the right place. You don't have to then say, oh, the last one. Is there anything smaller than me in me? Boom! Hit that explodes. Anyway, this says, hey, the one that was smallest is. It assumes, hey, the one that's smallest is the current one. But then it goes through all the rest and says, hey, did I find a smaller one? And if it did, then it swaps them. Down here, it just swaps them. Anyway, I'm not going to make you write that. Anyway, this sort method, same attributes for this one. It's also relatively easy to code, and it's quick for small data sets, and it gets very inefficient for large data sets. So both these algorithms can work with arrays and array lists. But my code there was with arrays. So let's do a practice. What does this data look like after 3 passes of an insertion sort? Can you get a piece of paper out and write it down? Or in the Notes app on the computer, just write 86793. And I want you to write down, I want you to tell me what, and we're talking about insertion sort. That was the first one we did.
The first pass never does anything, right? No, the first pass, you start the second element. So it's good thing. In this case,
this algorithm starts at the second element and checks should that thing be anywhere earlier in the list? So we're looking at the 6. Yeah, the 6 and the 8. The 6 should go in the first spot. So one pass, I've just given you a buy. One pass, the first pass is 68793. Um, 86793. Yeah. So what I would write in my notes is 68793, and then I'd write pass 1 next to it, just so you can keep track. I know that's very small up there, but I don't think I have Notepad Plus on here. Nope. That's a bigger font. So then we just need 2 more passes. So I gave you the first one, 68793. All right, I think I gave you enough time. Anybody want to be brave to say what it is?
No.
Fiona? That's not what I have. It's okay. Joseph?
67893.
Yeah. So listen, first pass I put up here. Second pass, it moves to 7. Third pass, it's looking at the 9, so there's no change. You're definitely the 3 would be the next one, but I just so I guess I forgot. Fourth pass, it's sorted. I personally had only done 3 passes, but yeah, the fourth pass it looks at that 3 and puts it up front. So fully sorted. So you got to count one that has no change. That counts as a pass. And that was when it looked at the 9 here and found, hey, the 9 shouldn't be earlier. So we're not making any changes. And then it looks at the 3 and puts it on the front. So let's do the same thing, but with a selection sort. All right, everybody, you got your place to write. Selection sort is a different algorithm. This is the one that swaps. I'll give you a hint. After pass 1, it looks like this. Pass 2, no change. Pass 3, no change. I'm going to go ahead and say this is an inefficient algorithm for large data sets. Pass 4, it's fully sorted again. So it finally gets to the 8, and it's or it's at the 9, and it's like, hey, yeah, I should trade this with the 8, and then by chance it's done. Well, it's done because it went through the whole thing. All right, so here's a recap of what I need you to get done today. The warm-up, if you didn't finish it. I'm going to post a Google form practice, which has you do two of these, just like what we just did. You should do that on paper, not try to do it in your head. Then we've got a practice REPL, this word group sentences REPL, where I can't wait to see your funny sentences. And then I want you to finish 9 through 18 on the AP Classroom. And today there's no Google form to submit. You just submit on the AP Classroom. Fiona? I wanted to, because I want to test on a block day, I wanted to do it next Friday, but I'm not going to do it next Friday. So. Wait, what? We're done with the new material for this unit. So it would normally be review next class and then test afterwards, but I'm not going to do that. I'm going to review twice. What? Well, I'm not going to do a test on a Monday, I don't think. So we might do review test. Because I'm being recorded, I'm not going to make a your mom joke. But yeah, I guess I just did in a way. But technically, I didn't. I can't get in trouble. Can I?
Only one way to find out.
I don't feel safe at home. I don't feel safe at home. For those of you at home, that was a joke. So no, we're not going to be tested next week. That'll be great.